Okay, so as we march on in our area study, let's dive into Euclidean geometry. If we're going to talk about Euclidean geometry, we get to finally recognize that rectangles exist, and that in fact is the bedrock of the idea of area in a Euclidean geometry. Every bit of understanding that we have about rectangles come into play here. So this is a rectangle. The area of a rectangle is its base times its height. This is the bedrock fundamental understanding of area in Euclidean geometry. The whole idea in Euclidean geometry comes from remembering that the area of a rectangle is its base times its height. Every other formula comes from that. So if you take the familiar area of a triangle, well, that's 1/2 base times height. Why? Well, drop the altitude to the longest side of triangle tri. Maybe it lands at point X. And then you copy triangle TIX out here so that these two triangles are congruent. And you copy triangle RIX out here so that these two triangles are congruent. Well, what shape is this? Well, that's a rectangle, right? It's a rectangle because whatever this angle measure is, that's 90 minus alpha, right? Because in a Euclidean geometry, this triangle has angle sum 180. And by the converse of alternate interior angles, right, this is a right angle. And similarly, this is a right angle. And so this big quadrilateral is a rectangle. But wait a minute. This is half of that, and this is half of that. So this is half of that. So the area of triangle tri is 1/2 base height. No tricks here. It's just really straightforward how we get the area of a triangle. And we can do this with parallelograms and trapezoids and all of the area formulas that you're familiar with from high school, from middle school. They all boil down to this formula. This formula is at the bedrock of every other area formula for polygons. I mean, obviously you can't do it for circles because circles are not polygonal, but you don't even know what a circle is because that's not till after exam 2. Okay, in the discussion, I'm going to ask you to prove a bunch of area formulas, as many as you think you can, and I'm looking forward to seeing how that goes.